This is my first attempt at a video live, so hopefully it goes well. This should help some with our first assignment in IM1. As part of the first assignment, we need to be able to tell whether or not a point is a solution to a system. This is really good for checking your answers. The main point in me giving you these problems on assignment 1 is when you get a solution to a system, we need to be able to check to see if that solution is actually correct. And this is how it's done. So on our first assignment, there's 6 or 8 problems where they say, is this ordered pair a solution to this system? So what that means is, if I plug it into the system, it works. So we have to try it in both of the equations. I'm going to start with the top equation first. Our x value is 3, our y value is 5. So if I plug in 3 for x, and I plug in 5 for y, I get the following equation. If I just simplify, I now have 8 equals 8. Things are looking good, right? In other words, this point lies on this line. But that's not enough. To be a solution to the system, it must satisfy both equations. So check mark number 1 is good, but we need to try one more time. It has to be on this line as well. The solution to the system is where these two lines intersect. So all we know at this point is that this point lies on this line. We now need to know whether it lies on the other line. That should be simple. X minus y has to equal 2. So if I plug in 3 for x, and I plug in 5 for y, I get this equation. 3 minus 5 is negative 2. And now I'm left with the equation negative 2 equals positive 2. Clearly that's not a true equation, so I'm going to say that they're not equal to each other. So the answer to the question, is 3, 5 a solution to this system, is a no. We need to satisfy both the top equation and the bottom equation. That has not happened. Let's try this one more time. Here, a potential solution has a fractional x value. Let's not worry about that. I'm not too worried because the coefficient in front of the x on both of these is even. So if we take half of an even number, I don't think we're going to be getting too many ugly fractions. So plugging it into equation 1, we have 4 times 1/2 plus 2y equals 14. 4 times 1/2 means 4 divided by 2. That's 2. And oops, I forgot to plug in my 6 for y, but I can do that now. 2 times 6 equals 14. So I'm taking one more step than I perhaps needed to, but let's just keep going. This is 2 plus 12 equals 14. And we always want to simplify completely, and here we get 14 equals 14. Things are looking good. But of course it has to work in the second equation as well. So, plugging both in at the same time this time, we have 8 times 1/2 minus our y value is 6 equals negative 2. 8 times 1/2 is 1/2 of 8. That's the same thing as 4. So simplifying a little bit further, 4 minus 6 is indeed negative 2. So I get the true equation that negative 2 is equal to negative 2. This exemplifies what should happen if we do know a point is a solution to a system of equations. All right, this is the end of my first video. There should be another one for substitution in a day or two. Thank you for watching.